In order to create a particle flow particle system, a particle flow source object must first be added to the scene. Then, you create events within the particle flow that tell the particle system how to work. First, add the particle flow source into this scene. In the Command panel, click the Create tab. In the Create Geometry dropdown, choose Particle Systems. Expand the Object Type rollout and select PF Source. In the Fountain Cam viewport, click and drag on the upper left side to create a small particle flow source object. In this case, the size does not make any difference. Now, in the Command panel, switch over to the Modify panel. With the particle flow source object selected, click Particle View in the Setup rollout to open the Particle View dialog box. Start out with the standard flow, and then add operators or change operators in the current flow. Click the Birth operator in the first event. Set the Emit Start to frame 0. Then, set the Emit Stop to frame 500. Since this particle system will be a fountain, you use a particle rate instead of the total amount of particles. Under the options, select Rate. Then set the rate value to 300. Make sure the subframe sampling option is selected. This will cause 3ds Max to sample the particles between frames, making the birth of the particles more consistent. Next, you will swap out some of the operators you currently have in this event. From the Operator toolbox, click and drag the Position Object operator on top of the Position Icon operator in the event. You'll see a red line going through that operator, which means that operator will be overwritten. Click the Position Object operator you just added. In the Position Object rollout, you need to add emitter objects. Click By List just under emitter objects. In the Select Emitter Objects list, hold Ctrl and choose both the Pillar 1 object and the Pillar 2 object, and then click Select in the lower right corner of the dialog. That adds these two objects into the Emitter Objects list. Once added, you set the location the particles will be emitted from. In the Location group, expand the Location dropdown and choose Selected Faces. This will cause the particles to be emitted from the black circle, which represents the water pipe on the top of the pillars. The reason this works is because the geometry for the water pipe circle has been selected in the polygon object. Next, click and drag the Speed by Surface operator on top of the Speed operator in the event and overwrite it. Now click the Speed by Surface operator in the event. Here you will set the speed of the particles that will be emitted from each pillar. In the Speed by Surface rollout, expand the Set Speed dropdown and choose Set Speed Once. Set the speed to a value of 10 feet and the variation to a value of 1 foot. Next, you'll need to tell the operator what surface geometry the particles will be coming from. Click By List. From the Select Surface Objects dialog box, press Ctrl and select both Pillar 1 and Pillar 2, and then click Select. This adds the two pillars to the surface geometry list. In the Direction group, expand the Direction dropdown and choose Surface Normals. Set the divergence value to 3. This now sets the direction of each particle based on the normal of the surface it's being emitted from, which will shoot the particles out at the ends of the pillars. Now select the Rotation operator in the event. In the Orientation Matrix dropdown, change the Orientation Matrix option to Speed Space Follow. Change the Z value to 1. This will cause the particles to follow the arc of their travel as they are emitted from the pillars. Now select the Shape operator from the event. In the Shape operator parameters, expand the 3D shape dropdown and choose Diamond Long. This is a simple shape with 8 faces, which will help reduce the polygon overhead when the scene is rendered. Change the size to 0.5 inches. Select the Scale checkbox and leave the scale value at 100%, but change the variation to 5%. Now click the Display operator in the event. Expand the Type dropdown and select Lines. Click the Color swatch and set the color to a light cyan by setting the red value to 9, the green value to 215, and the blue value to 180. Then click OK to accept the color. In order for this particle system to be a simulation, an mParticle operator needs to be added into this event. From the operator list, click and drag the MP Shape operator beneath the Shape operator in the particle flow event. You will see a blue line appear at the bottom of the Shape operator. Make sure the MP Shape operator is selected. From the Collide As dropdown, make sure Convex Hull is selected. Next, set the bounce and friction values. Set the restitution value to 0.2. Set the static friction to 0.1 and the dynamic friction to 0.1 as well. The next operator to add is the MP World operator. This operator is extremely important to the functioning of mParticles because it sets the parameters for the world these particles exist in. Click and drag the MP World operator to the bottom of the event. Now select the MP World operator. If the option in the MP World driver says None, click the Create New Driver button. Once a new world driver has been created, click the arrow icon, which is the More button to the right of the world driver name. This opens the options for this world in the Modify panel. Currently, there is nothing you need to change, but it's important to be aware of these options. The world for mParticles allows you to apply gravity and set its acceleration, as well as set a ground plane for ground collisions, and limits to the size of the world if there are any. Minimize the Particle View dialog box. If you want to see what this looks like so far, click the Play button and watch the particle flow as it is currently configured. Stop the animation and go to frame 0. The basic particle flow setup is complete.